All right, in number 1, our first task is to distribute this negative in and then rewrite our terms. So we end up with 3x minus x plus 1 equals 5x minus 10. Then I want to combine like terms on these same sides. I'm not changing signs yet. 3x take away x is 2x plus 1 equals 5x minus 10. Then I want to move variables to one side and numbers on the other. I typically like to keep the x's positive if I can. So I'm going to subtract off 2x, and at the same time I will add 10 to both sides. So on the left side I have 11, and on the right side I have 3x. And, oops, I'm getting ahead of myself there. Then it's just a matter of solving. So divide by 3, and so I get x is 11/3. Okay, over in number 2, I want to find a common denominator between x, 3, and 6. So I'm going to multiply both sides by the same expression. So I'm going to choose to multiply by 6x, because that would be the denominator that all three of those have in common. And I'm going to distribute that in, and that should get rid of my fractions. So 6x times 1 over x, that case the x's divide out, and I'm left with 6. 2/3, well, let's see, 3 goes into 6 twice, so that'll leave me with a 4x on that side. And then over on the right side, the 6's divide out, and I'm left with x. And then it's just solve good old-fashioned equation. So I'm going to subtract off 4x from both sides. So that'll give me a 6 here and a negative 3 here. Divide by negative 3. And so I get x is negative 2. Number 3, I'm going to go ahead and multiply by a common denominator. So that would be x plus 1 and x minus 4 to both sides. Now, oddly enough, when I do that, it's going to basically look like we're cross-multiplying. So here, the x plus 1's on the left side divide out, and I'm left with x minus 4 and x minus 2. On the right side, the x minus 4's divide out, and I'm left with x minus 3 and x plus 1. Then I want to FOIL, multiply that out. So x squared minus 2x minus 4x plus 8. And then x squared, let's see, plus x, whoops, minus 3x minus 3. And I can see some like terms on each side here, so I want to go ahead and combine them before I start moving sides. So it's a minus 6x on the left and a minus 2x on the right. Gotta make sure I don't switch signs on me. All right. Okay, so from here, let's see. If I move this negative 6x over, that'll give me a positive x somewhere. So let me go ahead and subtract off x squared from both sides and add 6x to both sides. And I'm going to move the 3 over, so I'm going to add 3 to both sides. So on the left, I have 8 plus 3, which is 11. And on the right, I have 4x, in which case, divide by 4, so I get x is 11/4. Okay, number 4, we're looking at a quadratic equation. So with quadratics, we got a couple different techniques we can look at using. For this particular one, I'm going to bring everything to one side, and then I'm going to try to factor it to start off with. So x squared minus x, and that becomes a minus 20. And I know if it is factorable, it's going to be x and x. And that number has to be something that multiplies to a negative 20, but consequently adds to a negative 1. So if I make my list of factors of 20, I get 1 and 20, 2 and 10, 4 and 5. And I can quickly see that 4 and 5, if I subtract, I get a difference of 1. So I want to subtract the 5 and add the 4. And then I want to set each of those equal to 0 and solve. And so I end up with a solution of negative 4 and positive 5. All right, number 5 is another great one for quadratics. In this case, we're going to use the square root method, which says I can take the square root of both sides, but I do get plus or minus. So in that case, if you take the square root of a square, that cancels out the symbol, and you're left with x plus 4. And here we get the square root of 81, which happens to be 9. And then if I bring that 4 over, I get negative 4 plus or minus 9. And then we'll split that off into two solutions, so negative 4 plus 9 and negative 4 minus 9. So that ends up giving us 5 and negative 13 for our two answers. Okay, number 6, this is a great candidate for completing the square. And the reason why I know that is I'm going to look at the middle term, and if the leading coefficient is x squared, so just 1 x squared, and there's an even number for the middle term, so the x, that's a great one for completing the square. So I'm going to bring the 10 over, so it's going to become plus 10. And then completing the square process, so I take the number, divide it by 2, gives me a negative 2, and then I square it to get 4. And so that's the magic number that I'm going to add to both sides to make this a perfect square trinomial. So on the left, that x squared minus 4x plus 4 factors into x minus 2 squared. And on the right, I have 14. Well, at this point, we can do that square root process that we just practiced on number 5. So I'm going to take the square root of both sides, get plus or minus. So I get x minus 2 equals plus or minus the square root of 14. And then I will add 2. So x equals 2 plus or minus the square root of 14. And as it turns out, that actually is done at that point. We can't simplify the square root of 14. So that's actually a perfectly fine answer. All right, and then our last case of quadratics that we're going to look at is the quadratic formula. So I want to first bring everything over to one single side. So 2x squared minus x plus 3 equals 0. Now, our middle term is an odd number, so it's a minus x instead of a 2 or a 4 or 6 or something, so that's why we can't use completing the square. It's not factorable, otherwise we would go about and do that. And you can play with the numbers if you want. So if you want to try to factor it and just convince yourself that that's fine, but like I said, I want to go straight to the quadratic formula. So I need an a, a b, and a c. So a in this case is 2, b is a negative 1, and c is 3. And then I want to set up our formula. And this is where I like to leave a bunch of blanks first so that I can remember or figure out whether it's positive or negative. So in this first blank, it's a negative b. It's a negative b squared minus 4ac all over 2a. Oops, too far. Okay. All right, so for starters, those negatives make it a positive, so I get 1 plus or minus the square root of 1 minus, I need 4 times 2 times 3. Well, that's 2 times 3 is 6, so that's actually 24 there, all over 4. And inside the square root, I end up with negative 23 over 4, and that's fine. That's complex, so I know I is going to show up here. So I get a 1 plus or minus I square root 23. Sorry, said it, didn't write it. That's actually a perfectly fine answer right there. So if we want to go further and just say it's 1 plus I square root 23 and 1 minus this I, that's fine. So our two solutions are that, or the plus or minus form of it is also fine. Okay, in the radical equation, I'm going to start by squaring both sides. Want to remind ourselves at the end of this, we do want to check our answer in the original problem and make sure that it actually, whatever solution we get does exist. On the right side, on the left side, I have 10 minus 3x, and I have x squared over on that side. Then I want to bring all the, it's quadratic, so I want to try to get all the terms together. So I'm going to bring the 10 and the minus 3x over. So that makes that plus 3x and then minus 10. Then I want to try to factor. So I need, let's see, 10 would be 1 and 10, 2 and 5, and that's it. And there are two numbers that have a difference of 3, and so I can see that if I make the 5 positive and the 2 negative, then when I multiply it out, I get x squared minus 2x plus 5x, so that I would get a positive 3x out of that. All right, so then I'm going to solve for each binomial, and I end up initially getting 2 and negative 5. So then I want to come back in and double check that this actually does work. So 10 minus 3 times 2 equals 2. All right, so that's 10 minus 4. And that's, I'm sorry, 10 minus 6. I'm getting ahead of myself here. So that's the square root of 4 equals 2, so that's 2 equals 2. Okay, so 2 actually does check. When I try the same thing with the negative 5, so 10 minus 3 times negative 5 equals negative 5. Well, here I already got a problem because on the left side I have a square root, but on the right side I have a negative number. And there's no way that the square root of anything is going to be negative. Best case, I get an I out of that. So that's my answer. So my answer actually is 2, but negative 5 just didn't check in the original problem.